This is AP Calculus Lesson 1-6. You can probably hear Riley in the background. Hopefully he doesn't start screaming. I'm not at school today because he threw up all over me. He's not doing so good. Make sure that before you start on this lesson that you have your summaries done from 1-5 and all the homework done from 1-5. Hopefully you guys had a good study session over the weekend with FaceTime or whatever you guys were going to do. Again, work on that homework for the first 5 minutes of class if you haven't finished it. Alright, so now you're done with your summary, done with your homework. Let's go through this lesson. So Mr. Sindell's paddleboarding lesson. Mr. Sindell went paddleboarding on June Lake last weekend. That actually did happen. There's that cool picture. The number of meters he has paddled at time t is modeled by a function capital D for t in between 0 and 60 minutes. Values of dt at various times are shown in this table below. So all I want you to do here is to graph those points. Pause it and do that now. Alright, so you've unpaused. And here are the points. So 0, 0, you do have to have this point down here. 550, 20, 350, 20, 350, 30, 800, 30, 800, 55, and 1350. 1350 is right here. And finally 60, 1800. Alright, so that's all you have. You're not connecting them with lines or anything. That's it. Alright, so average rate. That's all today's lesson. Average rate of change of f. And this is, so of a general function f. Not of this function in particular. Just what is average rate of change. And you should know that this is from Algebra 1. Another way of asking this is, what is slope? Do you remember the equation for slope? Write it down now if you know it. The general way that we write slope is this. We say f of b minus f of a all divided by b minus a. And you might be thinking, oh, it's y1 minus y2 over x1 minus x2 or something like that. That's okay. This is a more technical definition. It's the one you do need to memorize. This is going to be turned into a flashcard. Average rate of change means f of b minus f of a all over b minus a. This circles back around in later units too. So just try to remember, whenever I say average rate, there is a formula associated with it, and there is that formula. Have this memorized. And then there's a second fact that you also need to know from today's lesson. There's two facts. Fact number 1 is here. Fact number 2 is here. Both of those need to be memorized. Fact number 2, graphically, this average rate is represented as a line, just a really straightforward line between whatever points I'm talking about, whatever x and b, or whatever a and b coordinate I'm talking about. Alright, so example 1. Sketch the line representing the average rate of change over the entire interval. So the entire interval dt, again, that was defined between 0 and 60. So make a line from 0, 0 to 60, 1800. That is the average rate of change. So I'll do that in green, sure. Right there. Okay, that is A. And now B, find the average rate of change on that interval and indicate units. All right, so if we come back here, again, we're using this formula f of b. Well, f of b, we're going to say that 60 is b because that was the second, or I guess the last part of the interval. So it's going to be really f of 60, all of that minus f of 0 divided by 60 minus 0. All right, well, f of 60, well, I guess it's not really f. I should come back here and change that to, sorry about that. Let's do our erasers. This should be capital D if we're being correct, because we're not dealing with F anymore, we're dealing with this capital DT. My bad. Alright, so this should be capital D, oh, a little bit of lag there. Capital D of 60, capital D of 0. There we go. Okay, so D of 60, what is that? Well, when I plug in 60, I get 1800. So this is going to be 1800 minus, and then when I plug in 0, I get 0. So 1800 minus 0, and the denominator stays the same, which is just 60 minus 0, and that of course is 1800 divided by 60, which is equal to, I believe that's just 30. Let me just double check that. 1800 divided by 60 is indeed 30. Okay, but indicate units. You only get it correct if you have units. So what are our units? 30 watt per watt. Well, and it said in the problem it's meters per minute. So meters per minute. So we'll write this out as meters per minute. And there's our final answer. All right, we're on the back. It's kind of the same thing. Go ahead and do example 2 right now. All right, so from 5 to 20, you come up here and make another line. I will make this line a different color. Let's do orange between 5 and 20, and that represents the average rate of change. You might notice that when you're calculating the average rate of change, this unit right here, 30 meters per minute. Thank you, Riley. That is the slope. So average rate of change and slope, those should be synonymous in your minds. All right, and then part B, find the average rate of change on dt on the interval. So again, you're doing capital D of 20 minus capital D of 5. All of this divided by 20 minus 5. And we have to have units again. Riley. All right, and then if you have 20, that goes to 350. 350 minus D of 5, which is 50. All of this divided by 20 minus 5. That turns into 300 divided by 15. Mental math, don't know. 300 divided by 15 is 20. So this is equal to 20. And again, the same units as last time, meters per minute. So the slope between these points, 550 and 2350, the slope is 20, and the units are meters per minute. And the way that you find that is just by using the slope equation, which I'm going to be calling the average rate of change equation. So two things that are going to be added to the flashcards on Quizlet. This equation and graphically what it means to have average rate of change. Make sure you have those memorized. If you finish the homework early, go and do the Quizlet. It has a lot of things that we've already talked about. All right, that concludes this lesson. Don't do the summary yet. Do that for homework. Don't do it in class. Good luck, guys. Text me if you have any questions.